Welcome back. Take a look at this intriguing radical expression. It's a standard square root, with two more square roots nested inside. Our goal today is to break this down and find its simplest, exact mathematical form. Let's solve it strictly step by step. Step 1. When dealing with nested operations, it's almost always best to start with the most interior term you can easily resolve. Look inside the main square root. We see the square root of 49. This is a perfect square. The square root of 49 equals 7. Simplifying our expression to the square root of the square root of 50 minus 7. Step 2. Now let's look at the other interior term, the square root of 50. 50 is not a perfect square, but it has a perfect square factor. We can break 50 down into 25 times 2. This means the square root of 50 simplifies to the square root of 25 times 2, which is 5 roots of 2. Our expression is now the square root of 5 roots of 2 minus 7. Step 3. We have the square root of 5 roots of 2 minus 7. This still looks complicated. To proceed further, we need to apply the algebraic identity for simplifying nested radicals. Our goal is to transform the interior term, 5 roots of 2 minus 7, into a perfect square trinomial structure, which typically looks like the square root of a minus the square root of b squared equals a plus b minus 2 roots of ab. Notice the target form requires a coefficient of exactly 2 in front of the nested radical term. We have the term 5 roots of 2, the coefficient is 5, but our identity requires a 2. To fix this, we can multiply our radical part by 2 over 2 times 5 roots of 2 equals 2 roots of 2 times 5 over 2, which comes down to 2 roots of 2 times 25 over 4. Well, that's kind of messy. Let's try the common trick of dividing the interior term by 2 and multiplying by 2 outside later. We can pull a factor of 1 over the square root of 2 out by rewriting the problem as the square root of 1/2 times 10 roots of 2 minus 14 equals 1 over the square root of 2 times 10 roots of 2 minus 14. This is getting really messy. Instead, let's just make the coefficient of the nested radical term be part of our 2 times the square root of ab target. Let's rewrite 5 roots of 2 as 2 roots of a times b, going down to the square root of a times b equals 5 over 2 times the square root of 2 equals the square root of 25 over 4 times 2 equals the square root of 50 over 4 equals the square root of 25 over 2. To use the standard identity directly, it's often cleanest to create a fraction first by multiplying by 2 over 2. The square root of 5 roots of 2 minus 7 equals the square root of 2 times 5 roots of 2 minus 7 over 2, which equals the square root of 10 roots of 2 minus 14 over 2. We can factor out the square root of 1 over 2, or 1 over the square root of 2, giving us 1 over the square root of 2 times the square root of 10 roots of 2 minus 14. Now we manipulate the new nested radical part, 10 roots of 2. We want a 2 in front, so rewrite 10 as 2 times 5. Pull the 5 inside the radical, turning it into 25. 10 roots of 2 equals 2 roots of 25 times 2 equals 2 roots of 50. Our complex looking term is now 1 over the square root of 2 times the square root of negative 14 plus 2 roots of 50. Step 4. We're trying to solve the matching puzzle for the square root of negative 14 plus 2 roots of 50. We need two numbers, a and b, that add up to 14 and multiply to 50. This sign is positive because 5 roots of 2 is approximately 7.07, which is larger than 7. Since the difference is positive, our nested radical simplified structure should look like the square root of a minus the square root of b, where the square root of a is bigger than the square root of b. But wait a minute. Let's check our multiples of 50. 50 and 1 add up to 51. 25 and 2 add up to 27. 10 and 5 add up to 15. There are no clear integer solutions to this matching puzzle. This suggests that the nested radical approach with integers won't yield a simpler exact result. Step 5. Since the identity approach didn't give us obvious integer results, we return to our simpler step-by-step exact form. Our first major simplification gave us the square root of 50 minus 7. And our second major step simplified that interior radical to the square root of 5 roots of 2 minus 7. This is the simplest exact expression that can be written down for this problem. So our final simplified answer is the square root of 5 roots of 2 minus 7.